Welcome. In this session, I will discuss the definition of the derivative. Let's go back and look at where we started. In the very beginning, one of the problems we looked at was the question of defining the tangent line to a more general curve like a cube. We did x cubed. So if you recall what we did, we looked at slope of the line joining a given point, in this case 1, 1, to a nearby point x, x cubed, and looked at what happens as we made the second point x, x cubed closer and closer to the point at which we are trying to find the tangent. If you look at the graph, it looks like the tangent, a straight line that just barely touches the curve. So what we did was to take change in y divided by change in x, or difference in y divided by the difference in x. There was another situation where we had the same thing. This was the very first example where we tried to define the speed of a falling object. We looked at the distance traveled, defined as change in the position divided by change in time. So again, we have a ratio of changes, and we looked at what happens as we made that interval smaller and smaller. So more formally, we can say that if we take the interval of time from t to t plus some small change in t, we look at the change in the distance and we take the ratio, and then we found the limit. At this point, I'll also go ahead and introduce the standard notation. Often to denote change in some quantity, we use the Greek letter delta, capital delta, which looks like a triangle like this. So delta t will mean change in t. Delta s is the change in time. So in other words, what we did was change in dependent quantity divided by change in the independent quantity, or equivalently change in the function divided by the change in the variable, and then took the limit. Now we are going to look at this more mathematically. Now that we know something about limits, we can do this in a more systematic fashion. Okay. So if you have a function f and a number c, and the quantity f of x minus f of c over x minus c has a limit as x approaches c, then we call this quantity the derivative of f, denoted by this symbol, f prime of c. The explanation for the choice of this symbol will become clear when we finish this section eventually. If this limit exists, we will say that f is differentiable at c. Of course, there is no guarantee a priori that the limit does exist. It's something we need to check. There are different ways to write this. For example, we can, instead of using x, we can use c plus h, where h is the change in the value of x. In that case, x will be c plus h, f of x is f of c plus h, and x minus c will be c plus h minus c, which is h. And as x becomes closer to c, h will go to 0. So we can write the limit as the limit of f of c plus h minus f of c over h. Often people use the delta notation. Instead of saying h, they say delta x, meaning the change in x. And the numerator will be written as delta f, the change in f. This leads to the alternate notation, the so-called Leibniz notation, where we write the derivative as dy over dx or df over dx. The use of fraction notation is supposed to be suggestive, but we need to be careful because this is not a fraction but a limit. It does behave like a fraction in a lot of contexts, but not always. And I will come back to this topic as the occasion arises. Okay. Now that we know how to find limits, we are able to do the calculations of this. So let's do a simple calculation. We will find f prime of 2, where f is the function given by f of x equals x squared minus 2x plus 3. So if I use this definition, I will take f of x minus f of 2 over x minus 2, find the limit. By its very nature, these are always of the 0 over 0 form. So if you have a polynomial function, we'll be trying to find the limit of a rational function. So you should simplify it as much as possible and then see if it has a value in the end. Usually it does, and that will be the derivative. So for this function f of x, if I do the difference quotient, f of x minus f of 2 over x minus 2, f of x is x squared minus 2x plus 3. F of 2 is what we get by substituting 2 for x. That's 2 squared minus 2 times 2 plus 3. That difference is divided by the change in x minus 2. Let's simplify the numerator. 2 squared minus 2 times 2 plus 3 is 3. So I have x squared minus 2x plus 3 minus 3. If I combine the like terms, 3 minus 3 is 0. So I have x squared minus 2x in the numerator. I can factor out an x, giving me x times x minus 2. Now I can reduce the fraction. X minus 2's cancel, so we just get x. And this is a polynomial. As x approaches 2, this has limit 2. So the derivative of this function at 2 equals 2. This is a basic idea of how to calculate the derivative. Of course, the devil is in the details of actually doing the limit calculation. We'll come back to this issue and how to get around it. Basically, that's what we are going to do over the next 2 or 3 weeks. But for now, we will stop here with just the definition of the derivative.